The area that we are in was originally evangelized by, and I grew up in Wisconsin, so we learned about this in a public school. Father Jacques Marquette and his traveling companion, fur trader Louis Joliet in 1673 and 1674. And we'll come back to that time period toward the end of the talk. But they explored Lake Michigan and down the upper Mississippi as far as Arkansas as early as 1673, 1674, which was commemorated by a public ceremony in Chicago in 1907 on the waterway where they returned back to the Great Lakes. So they started off in Sault Ste. Marie. So the Jesuits were working their way west and south from New France, and the Franciscans and others were working their way from the southwest up into the middle and evangelizing the indigenous people here. So we'll come back to that, but we just want to honor the risks and the sacrifices that they made to bring Christ to the New World. So ecosystem restoration in the Great Lakes has many parallel efforts around the U.S. on large ecosystems. So instead of restoring a single site, it's looking at a whole watershed primarily, or a large ecosystem like the Florida Everglades or Chesapeake Bay. So many of the approaches here have to span across state lines, across international boundaries, in the case of the Great Lakes, across disciplines. So they're inherently complex, they're inherently expensive, and they're kind of atoning for the sins of the past on a large scale. So to do them well requires not just scientific coordination and integration across disciplines, but also governance structures and advocacy and competing for the resources required to do it. You get a sense of some of the resources that have kind of amped up the progress in the Great Lakes over the last few years. So let me just introduce the lakes for people who aren't that familiar with them. You are here. 4 of the lakes are shared international water bodies. Lake Michigan is not, but the Canadians kind of consider Lake Michigan to be one of the 5 children, so they're always paying attention to what's happening in Lake Michigan. And routinely, when we're working on all of the Great Lakes, we don't leave one of them out. There's a medium Great Lake in the middle here in Detroit, Lake St. Clair. It's kind of on the way from Lake Huron to Lake Erie. But these lakes, 4 of the lakes, are mostly the artifacts of underlying geology interacted upon by glaciology. Lake Superior is different. Lake Superior is a rift lake. It was an attempt of the continent to split, and it only got so far, but in the process created a different type of geology up there. I'll touch on that again later. In that sense, it actually has analogs in the Dead Sea or in other deep rift valleys like in East Africa. So the population is concentrated in the southern parts of the basin. You can see all your favorite cities here. The one dot over there on the left-hand side is Minneapolis-St. Paul, which is actually outside of the basin, but the upper part of Minnesota does share some of the shoreline there with Lake Superior. And then the major Canadian metro area is Toronto. So they have a lot of interest in Lake Ontario in particular. So the lakes flow from the uppermost lake, Lake Superior, down into what's really one lake, Lake Michigan Huron. It's a single lake joined by a narrow strait about 4 or 5 miles wide at the top, where water actually sloshes back and forth depending on the wind direction. Lake Erie, a very shallow lake, but also the most productive lake in terms of fisheries and algae. And then a big drop over Niagara Falls, and then a series of drops down to the St. Lawrence River and the Gulf of St. Lawrence. So this is an internationally navigable waterway, either coming in through canals in the Chicago area or coming up the St. Lawrence River through a set of locks into Lake Ontario, a concentrated set of locks around Niagara Falls, and then a single lock at the outlet of Lake Superior. But other than that, the system is mostly unregulated in terms of water levels. And even those places where it is regulated don't really have the ability to change the water level by much. So I talked about governance a little bit. There are 8 Great Lakes states, one province on the Canadian side, Ontario. Approximately 120 bands of native peoples occupying the basin on both sides. U.S. tribes have 4 resource treaties, mostly governing use of resources in Lake Superior, Lake Michigan, Lake Huron, and some of the inland waters. And then the U.S.-Canada Boundary Waters Treaty and the Great Lakes Water Quality Agreement both govern the international interactions on the lakes, as well as a fishery treaty and some other international agreements. And then the Great Lakes Compact governs interstate activities, particularly diversions of water out of the lakes. So we'll start with a kind of a story of decline and death and decay, and then we'll end on a positive note and tell you where we've come from the bottom and maybe where we're headed a little bit. So one of the first environmental insults to the lakes was the logging that took place. It kind of peaked in the late 1800s, early 1900s. And this was sort of an extension of logging that began in New England. Some of the same families, the Yawkey family that used to own the Red Sox and others, once they finished logging off New England, they continued to the west and eventually the Pacific Northwest. But at one time, most of northern Wisconsin and Michigan, for instance, were almost completely clear-cut, particularly for white pine, but other species as well. And you can see that the peak of production of white pine in Michigan was actually in 1890. And the peak was actually, if you look at the units here, this is millions of board feet, so it's 4,000 million, so 4 billion board feet production of white pine, which to forestry people, that might mean something. To other people, it's just a big number. But you can see by 1910, Michigan is actually importing white pine. Another thing that happened in there was the Chicago fire, and rebuilding Chicago took a lot of that white pine leading up to the peak. Along with the logging was erosion caused by loss of the forest and severe habitat degradation in the tributaries that were used to transport those logs down to the mills. So what was done, a lot of the logging happened in the winter because you could build ice roads and carry loads like you saw here on basically a frictionless road as long as it didn't tip over. Stack up the logs along the river, and then in the spring when you had snow melt and higher flows, push them all down the bank into the river, which obviously destroyed the riparian vegetation and a lot of the stream bed habitat. And those systems are still recovering from that in terms of their grain sizes and the fish populations in them, and I'll talk a little more about that in a minute. So in addition to that, overfishing, particularly for the more abundant species, and I'll show you some data on that. So some of the what are now threatened or endangered or extinct species in some of the tributaries would include sturgeon. Lake trout was near extinction in many of these systems. Lots of other species were fished down below sustainable levels, or at least commercially sustainable levels. And this is just some data, not going all the way back, but back to early 1900s. The black lines here are U.S., and this is commercial yield only. The gray lines are Canadian. And what you can see overall is a pretty substantial downward trend to the present, with the exception of Lake Erie. So Lake Erie actually had a commercial rebound that's primarily walleye and perch, and you see the rebound is primarily on the Canadian side. So there's a large commercial fishery for walleye and perch in Canada, no commercial fishery to speak of in Lake Erie on the U.S. side, but a lot of charter boats and recreational fishing. Invasive species. So the lakes are kind of a poster child for invasive species. They've been heavily studied. You'll see a little data in a minute. Two of the most well-known and most problematic have been sea lamprey, which was introduced, some debate about how it was introduced, probably up through the Welland Canal from a naturally occurring population in Lake Ontario, which is a parasitic jawless fish which attacks particularly lake trout and other large fish. And then on the right-hand side, you can see dracaenid mussels, starting with the zebra mussels, which were pretty quickly replaced by the quagga mussels. And this is just a coverage, for example, in Lake Michigan as they spread with no mussels present in the mid-90s. And then by 2010, a pretty solid bathtub ring surrounding the entire lake. So really massive and rapid colonization. These are non-natives transported in ballast water as larvae from Ponto-Caspian region. Another species I won't talk about, but they have a interesting relationship with, is a round goby, which is an invasive fish. The result of the mussel, because there wasn't any substantial filter feeding organism in the lakes, at least at the scale of these mussels, they fundamentally altered the food web. So they cause a collapse of the spring algal bloom in the lakes, and this is, again, data from Lake Michigan. So if you look on the left, you see a relatively large bloom in the spring once light limitation is overcome by the longer day length, and the nutrients used to fuel a large phytoplankton bloom, which is pretty effectively grazed away now by these filter feeders. So if you compare the left-hand side, Lake Michigan with the modern Lake Michigan, you see all of this algal biomass is gone, and in a 3D or a 2D slice, a simulation slice, if you compare the top and bottom over here, you see this is where all the phytoplankton are missing. So if the base of the food web goes away, upper food web obviously has impacts. Another issue, farm runoff. This one has not been solved, won't be solved anytime soon, but it's particularly problematic in water bodies that are shallow, that are warm, that have longer residence time, so the nutrients stick around for a while. And in this case, the limiting nutrient is primarily phosphorus, whereas in an ocean or estuary system, it's typically nitrogen. But the result is large algal blooms, particularly in western Lake Erie. This one is in September of 2017. But they're common enough that there's actually a twice-a-week forecast that's issued by NOAA with satellite images and numerical models to predict where that's going to move based on currents and winds. And then obviously climate change is having an impact in terms of ice cover, but also this is a paper just published in 2021 looking at 30 years of data from a deep string of thermistors right in the center of southern Lake Michigan here. So this is NOAA data, and what they saw is there's actually a warming trend, kind of erratic in the surface waters, but if you look at the deeper waters, you see this kind of winter warming trend in the midwaters that otherwise you wouldn't notice unless you had instrumentation out there for a long time to watch this going on, with obvious implications both for existing species and to potentially make the lakes more amenable to invaders that couldn't survive previously because the water was too cold, at least seasonally. Something even a lot of people that live in the Great Lakes don't know about is that there's actually offshore wells, not offshore oil wells, but offshore gas wells and pipelines on the Canadian side of Lake Erie. So this is like, I guess it would be analogous to Canada's Gulf of Mexico. They do prohibit oil drilling, although if you start drilling, you don't know if you're going to hit oil. So once you do, the rules are if you hit oil, you have to stop. Because if you had an oil spill in the lakes, this is drinking water for the major metro areas. So Deepwater Horizon spill in the lakes is definitely possibly even more problematic than in a saltwater system. There is a moratorium on the U.S. side for offshore drilling and even angled drilling where you'd start on shore and drill out underneath the lakes. So this is for now, it's only a Canadian phenomenon. Although despite that, there's also a lot of oil that passes through the lakes or through the region. So there are pipelines here shown in red. There are refineries shown in orange. The rail lines kind of that hug the lakeshore, both on the north and the south, have the potential for spills from train derailments and other accidents. A lot of North Dakota Bakken shale oil and Canadian tar sand oil passes through here. And with the changing in global petroleum dynamics due to the situation in Russia and Ukraine, even more of a demand for this transportation. So mining, we saw a great poster last night on reclamation of mine tailings, and I'll talk about tailings a little bit later, but some of the primary mining besides just the rock mining, limestone, dolomite mining, quarrying and salt quarrying around the lakes is in Lake Superior. So because of this rift origin, there's a lot of high-grade ore deposits, particularly iron ore and copper ore, but there's also gold and rare earths and platinum, other types of things around Lake Superior. So this is, in particular, a Lake Superior problem, especially lake shore mines or mines that are close to the lake and watersheds that can have associated pollution impacts and continue to even from legacy mines that have been long abandoned. A lot of that mining stayed in the lakes, particularly the iron ore was brought from docks in Lake Superior down through this lock on the St. Mary's River, and then to steel mills here in Gary and Chicago and several cities on Lake Erie. So that continues to happen. Those ore ships run back and forth as frequently as they need to supply the mills. They close the locks only very briefly in the winter from about January to March. And until that time, they've got icebreakers that actually run those ships through the frozen parts of Lake Superior and through the straits and up and down the Detroit and St. Clair River. So this is kind of, I don't know, maybe just a good image for as bad as it gets. So this is 1973, really just the dawn of the environmental era. We saw a lot of things going on around the early 70s yesterday, from encyclicals to legislation. I'll talk about that again in a minute. But this is kind of the example or representative example of what the state of the environment was at that time. Hard to imagine in terms of the emissions. Maybe even you drive through today, you think it's still very industrial, which it is. But there's a lot more regulation on what stays on the site versus what leaves the site. So that's the bad news. Now we'll turn the corner and start rebuilding. So a lot of this had to do with rules and regulations, but rules and regulations only happen if there's public support for them. So this is, what led to this is a combination of science, but also writing, really almost poetry, back to earth, back to nature movement. Work of Rachel Carson, writing of Aldo Leopold, the Sand County Almanac, leading to, in 1970, origination of the US EPA, National Oceanic and Atmospheric Administration, both created in 1970 the Canada Water Act, which we may be less familiar with, but also the US Clean Water Act that followed that in 1972. The Great Lakes Water Quality Agreement that I mentioned was first passed in 1972 as well. We're celebrating the 50th anniversary of that. Canada-Ontario Agreement, respecting the Great Lakes ecosystem in 1994, and subsequent renewals of that agreement. Great Lakes Fish and Wildlife Restoration Act, 1998, and then the U.S. Great Lakes Restoration Initiative that I'll spend a little bit more time digging into in 2010. So the Great Lakes Restoration Initiative, or GLRI, started in 2010. To date, it has funded over 6,500 projects, shown here on the map by the type of project. This is U.S. side only. Spent almost $4 billion so far, with an additional $1 billion added, I think earlier this year, late last year, by President Biden to accelerate cleanup of contaminated sites. It focuses on 5 different topical areas. One is toxics and AOCs, or areas of concern, invasive species, non-point pollution sources, particularly agricultural runoff, habitat and species, so restoration of habitat, restoration of species that are either absent or heavily depleted, and then some eye toward the future beyond the program, with education and other research leading to future restoration. So this is the areas of concern program that I mentioned. In 1983, 43 of these were designated. These are, I guess you could consider them kind of the Great Lakes version of aquatic Superfund sites, mostly industrial harbors and waterways impacted by various things that have degraded what they call beneficial uses, or BUI, so beneficial use impairments. Any given site could have up to 14 of these. So the process of getting off the list is restoring your beneficial uses. And so far, 6 of them have been delisted. Management actions are completed, 11, and 14 more are planned to be delisted by 2030. just last week I was in Muskegon, Michigan for an announcement by the Region 5 US EPA administrator that Muskegon Lake has now completed all of its restoration actions, which was 15 different projects totaling over $100 million to pave the way for its delisting later this year or maybe next year. So just a few examples of those projects. One that got underway a year or two ago was it was a cleanup of mining waste, in this case what they call stamp sands, which is after processing. It's not exactly the same as tailings, but similar to tailings from a mine that were deposited along the shore of Lake Superior and were actually, due to erosion and currents, moving to gradually bury an important spawning reef for lake trout. So the restoration process, in this case, it's sort of a temporary fix, but it's to take some of that material from the lake bed, pump it back up onto the top of the pile where it came from, and take it out of the water so it can't be eroded, and kind of a stopgap measure to keep this reef from being buried. This is another example, and this is being done all over at these areas of concern, is just either dredging of contaminated sediment, taking out of the waterways in these industrial areas, some of which you can see are still quite industrial, or in some cases capping in place if there's buried utilities or other things where excavation isn't possible. The habitat restoration includes lots of activities. Among them is restoring habitat for spawning, which has either been lost due to dredging of navigation channels or burial by excess sediment coming down from tributaries or other things. Interesting story, the images shown here are from the Detroit River. One of the targets was building spawning habitat for sturgeon. So this is a true case of build it and they will come. While they were actually putting the rock into the water, sturgeon appeared. And here's an underwater image of a sturgeon. So apparently they were just sitting there waiting for spawning habitat to appear. In the interest of keeping things out of the water, there's been a lot of replumbing of the sewer systems of Great Lakes cities, many of which were set up so that during storm events, the storm water and the sewage would combine when it overwhelmed the system and flow into the lakes. So again, at great expense, over $4 billion, the city of Chicago has rerouted its sewer systems with very large, deep, expensive tunnels running underneath the city, one of which now is connected to one of the large quarries that you might have driven over on your way here if you drove instead of flew into town, as a temporary holding basin, so that during storm events the water can collect there and then gradually be pumped back through treatment plants. So it enters the lake cleaner rather than in a big slug mixed with sewage during storms. PCBs, which were banned in the 70s, had a long legacy, but you can see that their concentration has declined in fish in all the lakes, and this is lake trout in particular, from highs back at the time that they were banned, down approaching what's almost an acceptable level of concentration for human consumption. So still bans on fish consumption in many areas due to PCBs, but approaching removal of that issue. The aquatic invasive species, the problem has not gone away, but at least it hasn't gotten any worse, so we'll take that as a win. So in about late 80s, early 90s, you can see this trend of increasing invasions kind of plateauing. And a lot of this is due to regulation of ballast water, particularly international ballast water movement, and exchange of ballast tanks in the open ocean, so that fresh water coming from Europe is exchanged with salt water in between to flush those tanks and then get rid of most of the freshwater species that might make their way into this new system. Talking about extinctions and undoing extinctions, extinction is forever, but local extinction means you might still be able to go grab what's left somewhere, like the California perch that we saw yesterday, and bring them back if the habitat is restored or logging's not going on anymore. So one example of this would be the Arctic grayling, which is extinct in the Great Lakes, but used to be abundant, is now a candidate for restoration. And these are some of the sites in the upper and lower peninsula of Michigan where grayling restoration is being considered. Sturgeon recovery is also underway, and we heard a talk about genetics and genomics and conservation yesterday. This was the result of a study done and published in 2010, looking at the existing sturgeon stocks in the lakes and saying if we're going to restore them, we might want to look at how similar or different those sturgeon stocks are. So, for instance, you probably wouldn't want to take sturgeon from the St. Lawrence River and restore them in Lake Superior. But even in Lake Michigan, you can see you've got one distinct population here on the western shore and a different population on the eastern shore, which actually seems similar to what you see all the way around the other side of Michigan. So the Michigan fish and the Wisconsin fish don't seem to interact with each other very much. It might be a Badger-Wolverine thing, I don't know. But this sturgeon recovery is a long endeavor because of the sexual maturity is so old for sturgeon. They're more like sharks. It's about a 30-year commitment. So they've successfully done it in Duluth, and they've really just started into it in Toledo in the Maumee River, which is a Lake Erie tributary. Some of the tools that are being brought to play here are fish acoustics. So in addition to genomics and seeing which stocks are where, now they can track individual fish, and they're moving toward expanding the real-time aspect of this. So you can track fish in real time, just like they can track your license plate on the Illinois Tollway and send you a ticket or a bill. I guess it becomes a ticket if you don't pay it. Track your license plate. So at this point, these receivers are scattered throughout. They're actually on a grid in Lake Erie. And in certain areas, Green Bay, you can see some other high concentrations of these. So you can watch individual fish that are tagged with these tags. Some of them have up to a 10-year lifetime, battery life. And they send out an acoustic signal. The receivers are just microphones, underwater microphones. But they can record that individual fish. And there's some really spectacular animations of walleye migrating back and forth across Lake Erie over the course of a summer. And the fishery managers never had anything like this information before. And it's completely revolutionized how they approach management of stocks. More toys, tools, and technologies. There's a $1 billion Great Lakes research, binational Great Lakes research initiative that's been proposed. It includes use of some of the technologies like these, so autonomous surface vessels like in this one here, solar powered. Here's a wind powered version that was deployed for the first time in the lakes. It had been deployed in the ocean, actually circumnavigated Antarctica. But this pair almost circumnavigated Michigan last summer. And then the one here is actually equipped with a toxin sensing device, kind of a lab in a can on a robotic torpedo. So this is deployed and developed for oceanographic work, but deployed in Lake Erie, where the problem is keeping it from running into the mud in the bottom because it's so shallow. Some other tools here, and the one on the left is an interesting one. This vessel is actually in the lakes right now. This is the newest and largest cruise ship on the Great Lakes. But there's interest in high-end cruise customers and kind of being scientist for a day, or at least for your cruise. And so it has the capability to launch Zodiacs out the back of the ship to take cruise passengers out and collect water samples or fish samples with scientists on board to tell them what they're looking at. There's a proposal to build an all-season, not necessarily ice-breaking, but ice-capable research vessel to use in the Great Lakes. The winter biology and winter processes are relatively unknown in the lakes, but important to figure out what's going on year-round. And this system is an autonomous vehicle that has downward-looking binocular video to do counting and identification of habitat for certain types of bottom-dwelling fish, particularly invasive gobies that I mentioned earlier. That one operated by the USGS. So back to the indigenous people. So the indigenous communities that have retained treaty rights have an ongoing active role in management of species. but even those that have not have a strong spiritual connection to the lakes. And we heard about the Kootenai tribe yesterday. Many of these tribes have not just a kind of a provisioning role in subsistence use of the lakes, but also a spiritual and even a family connection through their bands or their clans. So if you happen to be the sturgeon clan, you have a special affinity for sturgeon, not just for eating them, but it's a little stronger even than a allegiance to a wolverine or a badger. And so this has manifested itself recently in more advocacy for cleanup of the lakes and protection of the lakes. And you can see on the right even in many of these cultures, the women are considered the guardians of the water and of the agriculture. And so the water keepers are often the elderly women, the grandmothers. So you see a woman here blessing the waters on the right. We have our own indigenous saint, relatively recently canonized, Saint Kateri Tekakwitha, who is patroness of the environment. So maybe the sister of Saint Francis in patronage of the environment. She lived in 1656 to 1680, so actually overlapped with the explorations by Father Marquette. And kind of a product or a result of the martyrdom of some of the early Jesuit missionaries, North American martyrs. Canonized only in 2012. Here's a sculpture of her at the Basilica of the National Shrine of Immaculate Conception in Washington, D.C. So there was a 2019 USCCB report called Two Rivers, Report on Catholic Native American Culture and Ministry. A lot of the focus was on indigenous demographics and problems plaguing indigenous communities and pastoral issues. But it also called out the fact that the church has called to send missionary disciples to Native American communities to immerse themselves in the culture of the people, to borrow and incorporate elements of the Native American narrative that are in tune with the gospel, such as elements of Native American sense of restorative justice, family-centered spirituality, and I've highlighted historical environmental reverence. So this is a recognition that there are cultural elements of indigenous communities that should be harmonized with their Catholic faith. Many of these communities have members who their families have been Catholic for over several centuries, some 400 centuries, in some of the Spanish parishes in the Southwest. At the same time, recognizing that there are some problematic elements in some of the tribal beliefs. So not a syncretist, all spirituality is good spirituality, but taking the good and steering things away from problematic elements. So not to be outdone by the indigenous communities, this is a blessing of Lake Michigan by Bishop Mylan Latch, who's a Jesuit, but also a bishop in the Ruthenian Byzantine Catholic Church, Eastern Rite Church in union with Rome. So here he's making the sign of the cross in the waters of Lake Michigan with a wooden hand cross as part of a blessing of Lake Michigan at the Hammond Marina in Indiana, not too far from here in 2019. So I'll conclude with that. That gives us a sense of where we've been, where we've come, where we're headed, and maybe a little bit of the harmonization of science and religion in this case study of a restoration activity. So thank you very much.